Have you ever looked into a mirror and wondered why your reflection appears so perfect? Or noticed that a straw placed inside a glass of water seems bent? These fascinating effects are caused by two important properties of light: reflection and refraction. In this video, we'll learn what reflection and refraction are, understand the formulas behind them, and discover where they appear in our daily lives. Let's begin with reflection. Reflection is the bouncing back of light when it strikes a surface. When light hits a smooth and shiny surface, such as a mirror, it reflects back into the surrounding space. To understand reflection, we need to know three important terms. The incident ray is the ray of light that strikes the surface. The reflected ray is the ray that bounces away from the surface. And the normal is an imaginary line drawn perpendicular to the surface at the point where the light strikes. Reflection follows a simple but very important law called the law of reflection. The formula is theta I equals theta R. In mathematical form, we write it as theta I equals theta R. Here, theta I represents the angle of incidence, and theta R represents the angle of reflection. This means that the angle at which light arrives is exactly equal to the angle at which it leaves. For example, if a ray of light hits a mirror at an angle of 30 degrees, it will reflect away at 30 degrees. This simple law is the reason mirrors work and why we can see clear reflections. Reflection is used in mirrors, periscopes, telescopes, security systems, and many optical devices. Now let's move on to refraction. Refraction is the bending of light when it travels from one medium to another. For example, when light moves from air into water, its speed changes. Because its speed changes, its direction changes too. This change in direction is called refraction. That is why objects under water often appear displaced or distorted. The bending of light during refraction is described by a formula known as Snell's law. The formula is n1 sine theta 1 equals n2 sine theta 2. In this equation, n1 is the refractive index of the first medium. n2 is the refractive index of the second medium. Theta 1 is the angle of incidence. And theta 2 is the angle of refraction. This formula tells us exactly how much a ray of light bends when it passes from one material into another. When light enters a denser medium, such as water or glass, it bends toward the normal. When light exits into a less dense medium, it bends away from the normal. But what exactly is the refractive index? The refractive index measures how much a material slows down light. It is given by the formula n equals c divided by v. Here, c represents the speed of light in a vacuum, and v represents the speed of light in the material. The higher the refractive index, the more the light slows down and bends. For example, water has a refractive index of approximately 1.33, while glass has a refractive index around 1.5. Because glass has a higher refractive index, light bends more strongly inside glass than it does inside water. Refraction is extremely important in modern technology. Eyeglasses use refraction to help people see clearly. Camera lenses focus light onto image sensors to produce sharp photographs. Microscopes use lenses to magnify tiny objects. Telescopes use lenses to observe distant planets and stars. One of the most beautiful examples of refraction can be seen in nature. The rainbow. When sunlight passes through tiny water droplets in the atmosphere, the light bends and separates into different colors. This creates the stunning spectrum of colors that we see in the sky after rainfall. Let's quickly summarize what we've learned. Reflection is the bouncing back of light from a surface. It follows the law of reflection, where the angle of incidence is equal to the angle of reflection. Refraction is the bending of light when it travels between different materials. It follows Snell's law, which explains how the angle changes depending on the refractive indices of the materials. And the refractive index itself tells us how much a material slows down light. Thank you for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more exciting science content. See you in the next video.